In 4.4, we examine properties of matrices. Just as a review, and I remember going over this in the last lesson, we need to talk about how each number within the matrix is named. And we need this information in case we need to talk with one another, for example, via email or Zoom, where we can't just point. So, for example, I'm going to dive down here for a minute. I've always written it as E for element, but they've named this matrix A, so each of the elements in that matrix is called A. And then if you take a look at this number and this number, we can see here that this is row 3 and column 2. So the tendency for many people is to refer to that as A32. It's not. It's A sub 3, 2. And it's read separately because it's row 3, column 2. And this is a good point here. Remember that matrices, the dimensions are the rows by the columns. If the number of rows equals the number of columns, then the matrix is said to be square. So to determine whether or not two matrices are equal, there has to be a one-to-one correspondence. So if those matrices are equal, then x is 2, y is 1, p is -1, and q is 0. But if we look at this next example, x maps to 1, y maps to 4, but nothing maps to 0, so this is why these are not equal. Let's look at example 1. So in example 1, we're asked to find the values of each variable. If I were to literally take this and superimpose it on this, we can see w equals 3, x equals 2, y equals 1, and z equals 4. That's actually what you're being asked to do. In adding and subtracting matrices, to add them or subtract them, they have to have the same size, and you would add the corresponding elements. For example, if I were to take this matrix and put it over top this one, 5 plus -4 gives me 1. -6 plus 6 gives me 0. 8 plus 8 gives me 16. And 9 plus -3 gives me 6. Let's look at a couple of exercises. To add these matrices, I want to add the corresponding elements in each matrix. For example, element 1, 1 from the first matrix needs to be added to element 1, 1 in the second. So 6 plus a -8 is going to give me my first element. My second element is going to be -9 plus 2. My third is going to be 2 plus 5, or I should say this is 1, 1, 1, 2, 1, 3. Then 2, 1 is 4 plus 6. 2, 2 is 1 plus a -3. And 2, 3 is 3 plus 4. So that's how I can show my work. And then I get -2. and that's my final matrix once it's added. If a matrix contains only 0 for elements, then it's called a zero matrix. That's the remember 0 is the additive inverse. If you add 0 to a number, you get the number back. Inverses are going to be very important when we're working with matrices. So you want to know whether or not there's an inverse matrix where you can add the two matrices together to get 0. To do this, they walk you through an example where they check that. So -5 plus 5 does give me 0. 2 plus -2, -1 and 1. And you get the gist. So this is the additive inverse, or the negative of matrix A. Every matrix has an additive inverse. Just like in the real number system, you can add the opposite of a number. That holds true in matrices. That means that just like adding, we can subtract matrices. So -5 minus a -3 gives me -2. 6 minus 2 gives me 4. 2 minus 5 gives me -3. And 4 minus a -8 gives me 12. To multiply a matrix by a scalar, you distribute to each of the elements. So 5 times 2 is 10, 5 times -3 is -15, 5 times 0 is still 0, and 5 times 4 is 20. These are the properties. Multiplying matrices is not straightforward, not like addition and subtraction. To multiply two matrices together, you have to check the number of columns in your first matrix. So in other words, if you're multiplying A by B, the number of columns in your first matrix has to equal the number of rows in your second matrix. So we can multiply it. The resulting matrix, the product of AB, the size of it will be equal to the number of rows in the first matrix by the columns in the second matrix. So even though this first matrix is a 3 by 2 and the second is a 2 by 4, the product will end up being a 3 by 4. So now, a question is, can B times A be calculated? Remember that B is a 2 by 4 and A is a 3 by 2. These numbers do not match. Therefore, that product does not exist. So if we're asked, and we are being asked, to decide whether a product can be found, given that A is this matrix, which is a 2 by 3, and B is a 2 by 2, remember it's rows, then columns. So can we multiply a 2 by 3 with a 2 by 2? The answer is no. Can we multiply a 2 by 2 with a 2 by 3? The answer is yes, and the product will be a 2 by 3. In problem 33, we are asked to find the matrix product if possible. So the first thing we want to check is whether or not it's possible. The dimensions on this first matrix are 2 by 3. The dimensions on the second matrix are 3 by 1. That matches, so yes, it's possible. And our resulting matrix, the matrix product, will be a 2 by 1. Now, to multiply matrices, we're going to have to take each element in the first row and each element in the column of the second matrix in order to get the first element in the resulting matrix. So this first element is going to be 3 times negative 1, and yes, you do need to write out all this work, plus negative 4 times 4, plus 1 times 2. Then to find the next element, you have to take the second row times the first column. So 5 times negative 1 plus 0 times 4 plus 2 times 2. So there's a lot of work when you're writing down matrix multiplication, so you will have to write a lot. This is the first part of the work. The second part of the work is actually showing the negative 3 minus 16 plus 2, negative 5 plus 0 plus 4, and then that's negative 19 plus 2 is negative 17. Negative 5 plus 0 plus 4 is negative 1. So then that is the resulting matrix product. There are a number of real-world applications for matrices. Let's take a look at this example. A contractor builds 3 kinds of homes, A, B, and C, with 2 different styles, colonial or ranch. Matrix P shows the number of each kind of home that he's planning to build for a new 100-home subdivision. The amounts for each of the main materials used depend on the style of the house. The amounts are shown in matrix Q. Matrix R gives the cost in dollars for each kind of material. Concrete here is measured in cubic yards, lumber in 1,000 board feet, brick in thousands, and shingles in 100 square feet. So, what's the total cost of materials for all of the houses of each model? Yeah, you could figure that out individually, and that would take a while. It's actually faster to use the matrices. So to find the materials cost of each model, we find P times Q, which will show the total amount of each material needed, and then take that by R. So then that shows us the cost for building this planned subdivision for each of the 3 models. So, how much material should you order? And what is the total cost of materials? If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.